Okay, so ladies and gentlemen, let's talk about a U sub. So the idea is, ladies and gentlemen, is to take a more complex integral that may be dealt with when you have a composition, so when you have an f of g of x within your integral. And the idea is we want to rewrite your integral in terms of an easier, simpler variable, which in this case we call it a u. So the idea is in your integral, what you want to identify is you want to identify a function, and we'll identify that function as u. And in order for a u sub to work, within the same integral, you've got to be able to identify the derivative of u. So in other words, within the integral, u sub works as long as you can identify a function, and we'll just name that function g. So I'll replace this function g with u, and then within the same function, I can identify the derivative of g, and I'm going to call that the du. So the idea is I'm going to take what's a complex integral that may be a composition or product and rewrite it in terms of u and du. Like I said, this may or may not be possible. We are going to learn other derivative techniques. If u sub doesn't work, we will get into chapter 7 when we have what's called integration by parts, and we'll talk about tabular method. So u sub doesn't always work. Like I said, if you are able to rewrite your integral in terms of u and du, then you're simply going to integrate using the integration rule as we know, using your power rule or recognize your inverse trig. And then in the final answer, you'll replace your u by your g of x. And your answer needs to be in terms of x. Like I said, this u sub works for composition. It may also work for some products as well. So it works for composition, and it does work for some products. So the trick is, and this is what you guys, if you remember what made chain rule difficult for some of you in the beginning, was identifying that outer versus inner function. The idea is when you're looking at these integrals, what are you going to call u, and what are we going to call du? And for me, what I always recognize is look for u as being inside something. Not that it always works, but maybe being inside parentheses, maybe being inside square roots, maybe being inside of an exponent. So the same idea when you look for those inner function with chain rule, try see if that idea works. So here's an example where I've told you what u is equal to. So I've told you that u is equal to 1 plus sine t. Notice 1 plus sine t is inside a set of parentheses. Now, when you take the derivative of u, well, what's the derivative of 1? The derivative of 1 is 0. What's the derivative of sine? Now you're doing derivatives and integrals at the same time. This is why we took that basic quiz. The derivative of sine is cosine t dt. Notice in your integral, this is where that du comes in. There is where you can recognize that cosine t dt is the derivative of the u. So a u sub's going to work. So what I can do then is I can rewrite this whole entire integral as a u to the 9th du. So any questions about the substitution that I made? Now I'm going to go ahead and I'm just going to integrate using the power rule for my integral. So the integral of u to the 9th is going to be u to the 10th over 10 plus c. Now this is where you bring back, what did you replace? What was u equal to? U was equal to 1 plus sine t. So my final answer will be the quantity of 1 plus sine t to the 9th over 10 plus c. So any questions? 10th, yes. Just make sure you guys are awake, yes. 1 plus sine t to the 10th over 10 plus c. So any questions on how, again, the trick is rewriting that original integral in terms of u and du. So now let's take a look at b. So in letter b, first of all, before we get started even with u sub problems, what constant can I factor out of this integral or I can pull out? What can I pull out? A 3. So I'm going to pull out the 3 and I'm going to rewrite this as an x dx all over, and I'm just going to rewrite this as a 2x squared plus 5 to the 1/2. So now I've already identified what u would be equal to. U is equal to 2x squared plus 5. So notice that's inside the parentheses or inside the square root that was raised to the 1/2. So now what I want to do is I want to take the derivative of u. So what is the derivative of 2x squared? 4x. And then the derivative of 5 is 0 dx. Notice there's my x dx, which is a part of the integral. But what also do I have here that is not in my integral? I have this constant of what? 4. So what I want to do is I'm going to solve for x dx by doing what? I'm going to divide both sides by 4. So what is x dx going to be equal to? X dx is going to be equal to du over 4. So you may have constants that you are going to have to replace also. So now what I can do is I can replace x dx with a du over 4. And then I can replace this denominator, that 2x squared plus 5, I can replace it with a u. So now I can rewrite this entire integral. Again, I have that constant in the front that I've pulled out. 3 times du over 4 all over my u to the 1/2. Remember, du over 4 is just 1/4 du. So now I can pull out another constant out of this entire integral. What can I pull out? A 1/4. So I can take 3 and I can multiply it by 1/4. So that I have 3/4 times your integral. I'm just going to rewrite this as a u to the negative 1/2 du. So any questions on where I got the 3/4 from? So now I can go ahead and I can do my integration. So 3/4 times, again, I'm going to add 1 to negative 1/2. That's going to give me a u to the 1/2. Divide by 1/2, and I'm going to multiply by 2 over 1. So I have 3/2 times u to the 1/2, and don't forget your c. Am I done? No, because what do I have to do? Plug what? U, exactly. Remember, my final answer is not in terms of u. I need to replace it with that 2x squared plus 5 plus your c. So there's your final answer. Again, the idea is you're cleaning up your integral. You're making it a simpler form, so that way you can do the integration. Any questions so far on what I've done? So let's take a look at c. Again, du, I've identified u to be negative 3y. And like I mentioned before, look inside exponents, look inside square roots, look inside parentheses to identify what u could possibly be. So now you notice I'm going to replace the exponent with my u. So what is my du going to be? Du is going to be what? Negative 3 dy. Well, there's my dy. So to solve for dy, I'm going to have to divide by a negative 3. So negative 1/3 du is equal to dy. So I can rewrite my integral as e to the u times negative 1/3 du. And then what constant can I pull out? I can pull out a what? Negative 1/3. So I have the negative 1/3 times your integral of e to the u du. And then what's your integral of e to the u? Your integral of e to the u is just what? E to the u. So negative 1/3 times e to the u plus c. Is that my final answer? Nope. So what do I replace u with? I replace it with a negative 3y plus c. So any questions, guys, on that particular u sub? So letter D is an example of, as you can see, you have some type of product. So notice I've identified u as being equal to 1 minus x. And notice 1 minus x is inside the square root. So when I take the derivative of 1 minus x, what is the derivative of 1 minus x? Negative 1 times your dx. So I know I'm going to divide both sides by a -1, so that'll be a negative du is equal to dx. So what am I going to have to yank out of this whole entire integral? I'm going to have to yank out a what? What do I put in front of this integral sign? I'm going to put a what? Negative. So I'll have negative x squared times, I'm just going to replace this as a u to the 1/2 du. Wait a minute, I've got a problem. What am I going to do with this x squared? Well, this is where sometimes you have to do some manipulation with what you've set u equal to. U is equal to 1 minus x. So somehow I have to rewrite x in terms of u. Any thoughts on how I can use this u equals 1 minus x to help me? Solve for x, exactly. So what I'm going to have to do is I'm going to have to solve for x to help me get rid or replace x squared in terms of u. So if u is equal to 1 minus x, I know that x plus u is equal to 1, so x is equal to 1 minus u. So this is sometimes, like I said, we don't have a product rule for integration. This is one way we can manipulate a product of integrals, doing a u sub. But what we end up having to do is take that, whatever we let u be equal to, we end up solving for x. So now I can rewrite this as my negative 1 minus u to the second power times u to the 1/2 du. So any questions on how I change that x squared into 1 minus u to the second? You guys go ahead now and finish that. Again, what are we going to have to do first to integrate this? We're going to have to do what? What do we have to do? FOIL, and then we're going to have to do what? Distribute, exactly. So go ahead and FOIL and then distribute for me. Hopefully we came up with that ugly answer right there. And again, I didn't distribute the negative sign that was in front of my integral to every term. I just left it in front, which is fine. If you distributed, that's fine, or if you left it pulled out, that's absolutely fine as well. Again, my constant is just a constant, so again, you don't need to include that plus c with the negative sign. Yes, Sam?
Since the integral was inside the grouping, or sorry, since you factored out the -1 and you integrated what was inside, wouldn't the c also be negative?
It's a constant.
Oh.
So whether it's a negative constant or positive constant, it's still a constant. So you don't have to include the, I mean, it wouldn't technically be wrong if you had the negative sign in front of it, but a constant is a constant is a constant. All right, so this, in case you need to see my work, this is what I came up with. So any questions on that one? So like I said, when you deal with products of integrals, most of them are not going to be pretty. When we get to chapter 7, when we get to parts, you'll see that it's not the prettiest integration. You'll appreciate the product rule of derivatives. Any questions on the u sub so far? So like I said, sometimes the trick is being able to identify what u is equal to. So now, let's see if we can identify what we should have u be equal to. So let's take a look at example 2a. So now I'm not telling you what to have u equal to. Anybody want to take a wild guess what we should set u to be equal to in 2a? Yeah, x to the 4th by 3. So one thing I always do is I look to see, all right, if I'm dealing with x's and it looks like powers, try and let u be equal to the x with the highest power. So for example, I'm going to let u be equal to x to the 4th minus 3. So if u is equal to x to the 4th minus 3, du will be equal to 4x to the 3rd dx. Well here, remember it's multiplication, so order doesn't matter. There's that x to the 3rd dx. If I rewrite this as the square root of u to the 1/2, there's my x to the 3rd dx, which is all going to be my du. But now I have this constant. So what am I going to have to divide both sides by to solve for x to the 3rd dx? Yes, Val?
Sorry, but why would it be the square root of u to the 1/2?
Oh, it should just be square root of u. I think I meant to do just u to the 1/2 and I got carried away. So what am I going to divide out here? I'm going to divide out a, what constant am I going to have to, because I got to solve for x to the third dx. So what do I have to divide by? 4. So then I can rewrite this as my u to the 1/2 times du over 4. So now what constant can I yank out of this interval? I can yank out a what? 1/4. So I have a 1/4 times the integral of u to the 1/2 du. So any questions on how I've rewritten this particular integral in terms of u and du? So now when I integrate, I've got 1/4. Don't forget about that constant. If I add 1, that's going to give me a u to the 3/2. I divide by 3/2, which means I'm going to multiply by 2/3. So 1/4 times 2/3 is going to give me 1/6. I can bring back in that x to the 4th minus 3 to the 3/2 plus c. So any questions? Again, you have to be really careful of those constants when you pull them out. All right, any questions on how I got that one there? Now let's look at B. Any thoughts on what you think we're going to let u be equal to here? 7 theta. Again, look inside your trig function, just like when you did chain rule with derivatives. Look inside your trig functions. So I'm going to let u be equal to 7 theta. So what's my du going to be? My du is going to be what? 7 d theta. Again, there's my d theta as part of the integral. So to solve for d theta, I'm going to have to divide both sides by what? 7. So that I can rewrite this integral as secant squared of u times du over 7. So then what constant can I divide out of this or bring out of it? I can bring out a what? 1/7. So I have 1/7 times your integral of secant squared u du. So the question is, what is your integral of secant squared? What function has a derivative of secant squared? Tangent. So my answer is going to be 1/7 times the tangent of u plus c. Is that my final answer? No, because now what do I have to replace u with? I'm going to replace u with 7 theta. So any questions on B? Now let's take a look at C for a minute. So when you see, now you agree with me that another way I could write this integral would be 1 over 1 plus 25x squared dx. You agree with me that those are equal? So any thoughts on possibly what integral is this going to be? It's probably going to be, when you see these 1s over a square root or 1 over 1 plus something, this is where you need to be thinking of inverse trig. So the trick is, however, if this was just a 1 over 1 plus x squared, which inverse trig function would this be? Inverse tangent, the inverse tangent. But the issue is, I don't have just an x squared, I have a 25x squared. So I can use a u sub, what if it looks like it could possibly be an inverse trig, but what I need to do is I'm going to have to rewrite this 25x squared as some base raised to the second power. So I can rewrite this as a 1 over 1 plus the quantity of 5x raised to the second power dx. Because you agree with me, 5x to the second power is equivalent to 25x squared. So now, what do you think I'm going to let u be equal to? U can be equal to what? 5x. My du then is just going to be 5 dx. So there's my dx. Here's my dx. To solve for dx, what am I going to do to both sides? I'm going to divide both sides by 5. So now I can rewrite this whole entire integral as 1 over 1 plus u squared times du over 5. So a lot of times, ladies and gentlemen, with these inverse trigs, you do have to do some algebraic manipulation to get it in the form of an inverse trig in order to be able to set up a u sub. So what constant can I pull out of this interval? I can pull out a what? 1/5. So I have 1/5 times your integral of 1 over 1 plus u squared times du. Now, hopefully you recognize this. 1 over 1 plus u squared is going to be 1/5 times your inverse tangent of u plus c. And remind me again, what was u equal to? U was equal to what? 5x. So I have 1/5 times your inverse tangent of 5x plus c. Yes, Chris?
Can you just like do the natural log?
No, because it's because you have that 1 added to it down there. Plus, it's not an x; it's an x squared. Because you have a sum. Back up. You could, if this was just an x.
Can you just replace 1 plus 25x squared with u and then make it 1 over u?
But then you have u would be equal to 20. But remember, you have to find your du, and that would give you a 50x. The problem is there is no x in the numerator. If there was an x in the numerator, you would absolutely do that. But the problem is you'd be stuck because there's no du with that x.
Okay.
I wish I could say yes to that question, Chris. I know it'd make it a lot easier, but no, sorry. All right, look at D. Any thoughts on what you think u is going to be equal to? And I ran out of room, so I'm going to get a separate sheet of paper here. Now, remember trig notation, guys. When you see this sine to the 6th of 5t, remember you have cosine of 5t times the quantity of sine of 5t to the 6th power dt. Remember that sine to the 6 is actually the quantity. So do you have any thoughts? First of all, you've got a product. So right away, this is an idea. You have a product and you have a composition, a function within a function. So this is where u sub needs to be coming to mind. Do you have any thoughts what you're going to let u be equal to? Sine or cosine? What do you think? Sine. Notice sine is inside what's raised to the 6th power. So I'm going to let u be equal to the sine of 5t. What's my du then going to be? Well, what's the derivative of sine? You have to use your chain rule. What's the derivative of sine? Cosine of 5t times what? 5. So notice, here is my du. There's that cosine of 5t, which is right here. But to solve for cosine of 5t, what am I going to have to divide both sides by? I'm going to divide both sides by a 5. So cosine of 5t is equal to du over 5. So then I can rewrite this integral as u to the 6 times du all over 5. So any questions on how I rewrote this really ugly integral? Yes, Izzy?
Did you forget
The what?
the dt?
Oh yeah, I'm sorry. Thank you, yes. Sorry about that. So now what constant can I yank out of this integral? I can yank out a what? 1/5. So I have 1/5 times your integral of u to the 6th du. So I have 1/5 times. Now I integrate u to the 6th, that's going to give me a u to the 7 over 7. So 1/5 times u to the 7 over 7 is going to give me 1 over 35 Again, my u is that sine of 5t to the 7th power, and don't forget to add your c. Yeah, you will get some ugly constants. Remember, guys, you can always check your answers, right? So what can you do to check your answers? You could just simply take the what of your answer. You could take the derivative. All right? So any questions on that one? So any questions on when you have the u sub? We did a little bit, so this is the trig ones. Like I mentioned, sometimes you have to do some algebraic manipulation when it comes to inverse trig. So let's take a look at 3a. We have the square root of 9 minus 4x squared. First of all, remember that dx in the numerator, you could rewrite this as 1 over the square root of 9 minus 4x squared dx. I didn't do what? You need my work back here, good? Let's talk about the last one. This is my cosine of 5t dt, which was right here. That's all my du. I just didn't reorder. Yeah. If this was a 1 minus x squared in the denominator, which inverse trig would this look a lot like if this was a 1 minus x squared underneath the square root? Is it inverse sine, inverse cosine? Which one is it? Inverse sine, inverse sine. So what we're going to have to do is we have to do some manipulation here so that we can get it a 1 right here. So in order to do an inverse trig, what we're going to have to do is we have to factor a 9 out of what's underneath the radical. So when I pull out that 9, that's going to give me a 1 minus 4x squared over 9 dx. So you agree with me? I haven't changed the value of the denominator. I've just changed the appearance. Do you agree with that? Because if I was to redistribute the 9, it would be equivalent. Now, this 9 is underneath the square root. There's a constant now that I can pull out of this integral. Because what is 1 divided by the square root of 9? 1/3. So right now I can rewrite this as 1/3 times your integral of 1 over the square root of 1 minus. Now, just like I did with the inverse tangent problem a few minutes ago, this would be really nice if it was just an x squared. So I need to rewrite this as a base to the 2nd power. So I can rewrite this as 2x over 3, all raised to the 2nd power dx. So when you see that coefficient in front of x squared and it's set up to possibly be an inverse trig, this is where you're going to be having a u sub problem. So now, how am I going to integrate this? I can do a u sub. So what's u going to be equal to? U is going to be equal to 2x over 3. So then what's du going to be equal to? Du is just going to be what? 2/3 times your dx. Well, here's my dx right there. What am I going to have to divide to solve for dx? I'm going to have to divide both sides by what? 2/3, which means I'm going to multiply by 3/2. So 3/2 du is equal to dx. So that I can rewrite this integral, just so I'm not squished, I'm going to do it over here, 1/3 times your integral of 1 over the square root of 1 minus u squared times your 3/2 du. Some of you are going to start and you're going to be able to recognize that this 3/2 is going to be pulled out in the integral, and you're going to start just putting the du here and the 3/2 in the front, which is fine. I'm just showing you to illustrate the substitution. Because now, what constant can I pull out of this integral? I can pull out a what? 3/2. So I need to multiply then 3/2 times 1/3. So what constant's going to be on the front then? It's going to be a constant of what? When I multiply 3 halves by 1/3. It's going to be a 1/2 times 1 over the square root of 1 minus u squared du. Finally, now I'm ready to integrate. Because all I've done right now is algebraic manipulation and substitution. Now I'm finally ready to integrate. What integral is 1 over the square root of 1 minus u squared? That's going to be your what? Inverse sine. So I have 1/2 times your inverse sine of u plus c. And what was u equal to? U was equal to what? 2/3 x. So my final answer is going to be 1/2 times your inverse sine of 2x over 3 plus c. So any questions on A? So now let's take a look at B. Remind me again, the derivative of e to the x is, the integral of e to the x is e to the x. So if I take a look at B, since I've run out of room, I'm just going to do it on a separate sheet of paper here. I can rewrite this, if you want to, as your integral of 1 over 4 plus e to the 2x times e to the x dx. What's another way to write that e to the 2x? Think of your properties of exponents, e to the x squared. So if I rewrite this as 1 over 4 plus e to the x squared times e to the x dx. It would be really, really nice if this 4 was a 1 and this e to the x was just an x squared. Because it would look a lot like your integral of what inverse trig function, your inverse what tangent. Well, what do I need here? I don't need a 4, I need to have a what? 1. So what am I going to factor out of the denominator? I'm going to factor out a 4. So now what constant can I yank out of this entire integral? I can yank out the constant of what? What constant can I yank out? 1/4. So I have 1/4 times your integral of 1 over 1 plus. Now remember, in order to do inverse trig, I have to rewrite this whole entire quantity as a base squared. I have e to the x squared in the numerator, but I can rewrite this as e to the x all over 2 quantity squared times your e to the x dx. Now I've got set up to do a u sub. What do you think I'm going to let u be equal to? U would be equal to what? E to the x over 2. So then what's my du going to be? E to the x over 2, or 1/2 e to the x dx. Well, here's that e to the x dx that I need. So notice I've got the du as part of the integral. So if I solve for e to the x dx, I'm going to have to divide both sides by what? Divide both sides by 1/2, which means I'm going to multiply both sides by what? 2. So that I know that 2 times du is equal to e to the x dx. So then I can rewrite my integral as 1/4. Oh, one thing. You don't want to look at Google. There you go. 1/4 times 1 over 1 plus u squared times 2 du. So what constant now can I yank out of this integral? I can yank out a what? 2. So I can multiply the front by 2 as well. So 2 times 1/4 is going to give me 1/2. Times your integral of 1 over 1 plus u squared du. Because in order to inverse tangent, remember, it's got to be in this form. 1 over 1 plus x squared, or in this case, 1 over 1 plus u squared. So all we've done up to this point is algebraic manipulation to get it in that format. So now when I integrate, I can integrate this as 1/2 times your inverse tangent of u plus c. And what is u equal to? U is equal to what? E to the x over 2. So with the u sub, it's also used to help you do that algebraic manipulation when you've got a fraction where you have a coefficient of x squared especially, because you're going to reset that as that's what your u is going to be. So any questions on your inverse trig involving u sub? Yes, Izzy?
How do you go from the e to the second over, or to e to x over 4 then e to x over 2? Like g.
Are you right here?
Yeah.
So this numerator is the only thing squared. So it's just e to the x to the second power. So I need to raise this whole entire fraction to a power of 2. So the square root of 4 is 2. So if I square the numerator, that gives me an e to the 2x. So basically I took the square root of 4, which is where I got the 2 from. Because e to the 2x over 4 is the same thing as the quantity as e to the x over square. Because you need to get this whole, in order to do inverse trig, this whole base has to be raised to the second power. And that's going to be what your u is eventually going to be. Does that make sense? Okay. Any questions on that one? Any other questions so far on these u subs? Remember the first time you were introduced to chain rule? It was like, wow, that was like a math. That usually happens with u sub on integrals. You just take some practice. All right? So any questions on that one? Now, what you have to be careful of, guys, is a lot of times integrals are going to look very similar, but you're going to have different u subs and different ways to look at them in order to solve them. Look at A and B. Chris, this is kind of getting back to your question a few minutes ago. These two are they look very similar, don't they? What's the only difference? That x in the numerator. This x in the numerator makes the way you approach this whole entire problem differently. All right? Why are these two so different? How would you approach the first one? What are your thoughts? Could I do inverse trig? Could I set this up with the algebraic manipulation and do inverse trig? Yes or no? No. How come? The x. The x in the top makes it why I know that numerator to do inverse trig has got to be a 1. So the only thing I can do is try a u sub. What do you think I'm going to let u be equal to? U would be equal to what? Look at this whole entire denominator. 25 plus 9x squared. Because I know what's the derivative of 25 going to be. The derivative of 25 is just going to be 0. And what's the derivative of 9x squared? 18x times your dx. So notice, there's that x dx. That's already a part of the integral. But to solve for x dx, I'm going to have to divide both sides by 18. So then I can rewrite this integral as du over 18 all over u. What constant gets yanked out of this integral? I can yank out a what? 1 over 18. So I have 1 over 18 times your integral of du over u. So what's your rule to integrate 1 over u? That's going to be by what? ln. ln of the absolute value of u plus c. And then what's u equal to? U is equal to the ln of 25 plus 9x squared plus c. So that x in the numerator changes the whole approach to the way you're going to set up this integral. What do you think you're going to do for part B? Well, if this was a 1 instead of a 25, inverse trig. It's going to look like a lot like an inverse tangent. But what are you going to have to factor out of the denominator? You're going to have to factor out a what? 25. You guys go ahead and see if you can manipulate this one for me. Okay, guys. So hopefully we ended up with 1/15 times your inverse tangent of 3/5 x plus c. Okay? Again, when you let u be equal to 3/5 x, your du is 3/5 dx. So we have to divide by 3/5, which means we multiply by 5/3. So we know we have to pull out the 5/3 and multiply by 1/25. So any questions on? So like I said, a and b look like almost identical integrals. But that one x on the top completely changes the way you approach it. All right? So any questions on the difference between a and b? C and D, obviously, what's the major difference between C and D? You're dividing by x in letter C. So this is kind of going back to day one. Again, we don't have a quotient rule for integrals, so how did we handle C? What did we have to do with this fraction? We broke it up into two smaller fractions. So I can rewrite this as 25 over x plus 9x squared over x dx. So then remember, I can integrate term by term. So I have 25 over x plus 9x dx. So what is your integral of 25 over x going to be? When you integrate 25 over x, that's going to be what? Good question. 25 times your ln of x plus, what's your integral of 9x going to be? 9x squared over 2 plus your c. Remember, not every problem is going to be a u-sub. Yes, you have to be on the lookout for it from this day forward. But don't forget your basic integration that we did. Let's look at D. What's your integral of 25 going to be? Your integral of 25 is going to be what? 25x. What's your integral of 9x squared going to be? 9x to the third over 3 plus c. Or you can write it as 25x plus 3x to the third plus your c. You're lost, Gabe?
No, not so great.
You feel great?